Hello.
Hey Niels, how are you?
I'm good. How are you?
Good, good. Hey Alex. Niels, today TNG have the presentation, right?
Yeah, right. So today we will talk a little bit about Sentry and Bazel.
Okay. So in the agenda, I see there are 2 slots. So this is just one presentation, or there will be 2 topics, different topics?
2 topics.
Okay.
So each topic will be very small. It's only a quick overview.
Okay, sounds good. Let's wait for some time so others can join. Then we can start with TNG2. Hey Alexander.
Hi.
So you will be taking up the Bazel presentation, right? And Sentry.
Yes, I will. I'll just introduce the colleagues who actually present, but yeah, it's hey. So we're from TNG, and yeah, we're a team working on Magma now since about half a year, and yeah, we've actually located mostly in Germany, but not to forget our one colleague that is situated in Hungary. And we wanted to show you a bit of our work of the last half a year. Have been working on various parts of Magma, but mainly we have worked with the Python code, integrating Sentry there, and we've worked on the Basel effort. And my two colleagues that actually mainly drove these efforts will show you a couple of things shortly about what we've done there. And I think we would just start with whoever feels wants to start. Maybe Sebastian, do you want to start with Sentry?
Right.
Well, wait, just a second. How about we wait a couple of minutes so others can also join, then we can start. Is it okay?
Yeah.
Okay. Great, thanks.
Thank you.
If you have any presentation, then you can like bring it up. If not, then it's fine.
Not a presentation. I just wanted to give a demo in my browser.
Oh, okay. Then just give 1 minute, then yeah, we can start after that. So I guess we have enough people, so you can start now.
Right. Let me share my screen.
Yeah.
So I hope you can see the error monitoring and triaging workflow page now.
Yes.
Perfect. So the first thing I wanted to say is I'm only have a few minutes to talk about Sentry. So if you're interested in the topic, you should look at this wiki page where we've documented everything in much more detail. And basically, Sentry is an error monitoring tool. So the idea is that you can monitor errors that don't just happen in your test environment, but also can happen in deployed environments of the application. And we've introduced Sentry in particular in the gateway. So not really on the cloud side, but more on the device side. And we've introduced it so far for C++ and for Python. And Sentry works kind of differently for these two languages. So I just wanted to give a quick overview of both of them. The first one is, if you go to Sentry, the most important tab is usually the Issues tab, where you can see the errors that happened during the last 2 weeks. And Sentry has multiple projects, and the relevant projects for Magma are mostly these lab AJWS native and Python. So native is the C++ side, and Python is obviously the Python side. And this shows you a list of errors that were observed on Sentry for various gateways over the last 2 weeks. And I can just sort by events, so look at the most frequent errors first. And if I go on any of these errors, I can see the details that Sentry collected for this error. So these are interesting. For example, the text which shows you which release it happened in, which service was affected, hardware IDs, gateway names, and so on. And for C++, I mean, you see a stack trace and a list of registers, but usually it's not really human readable. So what you usually do is you look at these attachments and you download the dumps and the applications in the correct versions, which are also available here under the attachment page. And this allows you to run a debugger and to debug these traces and look at the error in much more detail. It's also explained on this page how to do that with LLDB. And maybe that's all about C++. Oh, one more thing is that it also uploads MME logs. And if you configure it on your gateway, it can also upload all Magma service logs. That's useful to do debugging for these errors. And on C++, it will only create an error if the application fails. So you see if you have a SIG abort or SIG terms, seg fault, and so on. And that's very different from Python, where it doesn't react so much on application crashes, but it reacts on error log messages. So if any of the Python services logs an error, we will see an issue in Sentry. And this is the reason why we see way more events on the Python side than on the C++ side. And here you can use Sentry much more itself to debug the error. You don't really need to download stack traces, but it will already show you stack traces on the Sentry side. It will show you breadcrumbs, so a list of log messages that happened just before the error. And just the same as for C++, you see information about which service it happened in, log level, and so on, release. And yeah, we've used this on the Python side to do some debugging. And if you don't want to look at Sentry constantly, there are also Slack channels set up that post new errors. Oops, sorry, and that for Python and for Sentry, for Python and C++ show you the errors that are that happen, that are new and that you should look at, basically. And what I should mention again about Python is that the main problem in the beginning was the amount of errors we saw. So there were just too many errors to really use Sentry. And because of course it reacts to all error log messages, and in many cases you don't just get log messages for errors that are related to bugs, but you also get log messages for configuration errors, or if some services aren't running. And here we really want to have an error because the operator needs to see that a critical error occurred, but they are not really relevant for developers for debugging. So what we introduced is a flag on Python error messages. So if you do a Python logging error, you can say exclude from error monitoring, and then it will not be sent to Sentry. And we had to introduce this in around a dozen different places to get rid of the most frequent errors that are not relevant for us. And now Sentry has become pretty usable. And I think that's it from my side. Any questions about Sentry?
I've got a question for you.
Sure.
Was this used to figure out any errors that we didn't know about? Like, what was already useful?
Yeah, so we have seen a few bugs that we didn't know about, where like null pointer bugs, or where some types were not set correctly. And there are also quite a few issues about, especially in pipeline-D, where we're still investigating, that were shown on Sentry, and I'm not sure if they have been fought in other ways too.
Awesome, thank you.
All right. If there's not any more questions, then Niels will continue with Basil.
Great.
Yeah, thank you very much. Then about Basil, there is this ongoing effort that was initially driven by Marie and Scott from Meta. The point is that we we want to migrate from the current CMake builds to Bazel builds. There are a couple of benefits. One, but not all, are that Bazel supports massive caching, decentralized definitions of build targets, reproducible builds, and many more. From TNG, currently a small group is working on this. This is Chris, Lars, Jan, and me. And I want to show something that is already migrated, so you have a better feeling what we are working on. So let me grab the screen. So I'm currently on the virtual machine, and I want to start a service, SubscriberDB, that is a Python service that is already Baselified. So let's first check if SubscriberDB is currently running. Yes, it is. And of course, we want to stop it because we want to run the service with Bazel. So let's stop it. And what we do is Bazel run. So always start with Bazel, then some verb. In this case, we want to run something. And SubscriberDB is localized in LTE, gateway, Python, Magma, SubscriberDB. And if we start it, we see it turning up. And it is started, and it is listening on the on this address. And this was pretty fast. The reason was because I started the service before, so everything was built. And as I said, Bazel benefits from massive caching. Running a service is, of course, not all. What we also want to do is run the tests. For this, we can use Bazel test, again, LTE, gateway, Python, Magma, SubscriberDB. And there's this ... notation. We want to run all tests that are Baselified for SubscriberDB. And again, I hope I can predict that this will run really fast because I executed it before, and it did. So there are a couple of tests. Each test passed for now, and you can see that the result was cached. So even the test results are cached if there is no change. And you can see one test run in 11 seconds. This was actually now faster than 11 seconds. So that was cached as well. But these are the actual run times. If there is, of course, a change in the logic or in the test, then the targets will be built again, and everything will be, the run will take a little bit more time. Let's take a quick look how this looks like in code. So, as I said, Bazel has decentralized definitions, so we don't have one makefile for Python completely, but basically in each folder we have such a build Bazel file, and this is currently on master as well. And for our example here for SubscriberDB, what we see here is, sorry, a rule, a pi binary. So like the name suggests, we have here one bundle that is, modeled in Python service, SubscriberDB. And the rule is pi binary, and it defines the target SubscriberDB. Of course, there's a main.py involved and a lot of dependencies. We have dependencies that are source files, model source files in the service for SubscriberDB. For example, here, subscription profile pi, and this is then a pi library that is used in the binary. And there's a benefit in having small targets, for example, only a couple of source files in one library, because then Bazel is caching the build targets, and then if a change in subscriber profile happened, then not a lot of code needs to be compiled again if the tests are executed, for example. Please excuse saying compiled in Python terms, but the idea is the same in C, C++, and in Go targets. For tests, it is similar. For each test, we have a rule PyTest that defines the target for a test. For example, here the client test, and the test as well has some dependencies. Let it be Protos dependencies, so generated protofiles, which is also possible with Bazel, or here by requirement dependencies on actual pip dependencies. Yeah, so this is only a small glance at what is currently possible with Bazel. We have a couple topics where we are currently working on and which are planned for the future. For example, more migration, so migrate each service, have a deeper integration in the CI process, so actually use the Bazel-fied services in CI. The tests, of course, run already in CI, and have a deeper integration in the current development processes. Yeah, this was basically what I wanted to show. So are there any questions or comments? Not so far. Then I can pass over to the next speaker. Thank you.
Okay, thank you. So for 5G updates, we have Daljit.
Hi, good morning, everyone. I'll just share my screen. Right? Can you see my screen?
Yes.
All right. So we start with the similar way at past. So the 5G SA Alpha release is out as of March 30th. So that part is completed, and the team is continue working on 1.7. I said X, but it's 1.7.1 most likely. Nothing else comes in. So that's we are working on some of the feature, plus there's another feature GTP programmable extensions that's still in development, and we are doing continued regression and scale test. This is just highlighting the 1.7 features which are already released as of as alpha in 1.7. So I think they're already, people are aware of it. So I'll pass on to this. This is the hardening for regression testing issues. So we have a lot of issues found and fixed, and we have 2 crash fix here related to encoding, decoding, and one is tied up with the DNS encoding length issue. And also there's another decoding failure issue related to UE security capabilities with all the extended values. Next set of fixes are related to, related to error handling and cleanup. So there's a error handling related to with this pipeline D and tied up with the UE info in MME. So that's fixed. The handling of session PDU, and this is a cleanup of a stale session is handled properly now. And the next one is related to configuring the policy AMB QO5 value. And this is basically the issue related to configuration, and it was now getting reflected in the AMF. And there's just some debug option related issue fix in that Python file. Next set is a couple of Bazel test related issues fixed. So basically all test cases are enabled with and remove the manual tag. And then we have another test related to stateless and procedure, which is fixed, and it's using mock APIs instead of gRPC calls. And then the last set is the issues related to implicit deregistration. A whole bunch of steps in there in the PL which are got resolved and merged. And then CTP shutdown in NGAP protocol. That part is also fixed. So if anything to discuss here, otherwise we can move to next slide. All right. So this is the 1.7.1 or 1.7.x 5G features we are tracking. First is stateless feature, which is basically is ready for release. All the regression and scale tests are okay. With IPv6 support, we found some existing issue, and this is under verification right now in the latest build. In regression and scale test related issues, and this is a text basically is a continued testing and fixing and merging the issue. One issue is still pending for merge, and we are fixing the issue we found during the merge. GTP extension support is the only feature which is mainly still in development, and we have basically we need to port the fixes we were done into the new versions for OBS and RYU. So though that part was completed, and OBS enhancements are very much done and PRs are under review. RYU enhancement development is in progress, so no blocking issues at this stage. I went too far. Yeah, this is the last slide related to the testing. So 1.7.1 testing is planned. We are working on it, and we are working on increasing the scale numbers, and we are working on more even high performance and more load testing and increasing the bandwidth we can use with various scenarios. So that testing will continue. So nothing additional update here. And any questions we can look into, other than this is very much we have today. Alrighty, so I think we are good. Shubham, I think that's very much from our side.
Thanks, Arijit. So from DevOps side, I can give the updates. You can stop sharing, Arijit.
Yeah, I know. Every time I try stop sharing it, I can't do. I don't see option. My this whole thing goes into weird stage. I end up by just exiting. Let me see if I can figure it. You can continue. I'll just try to figure it out.
Okay.
Yeah.
So from DevOps side, there are a few updates. First thing regarding the release process. When we do release, there are a lot of things that we do, and one part is releasing the latest Helm charts and Docker images. So previously, this process was manual because we have 4 different Docker repositories for Access Gateway, Federation Gateway, Orchestrator, and Carrier Wi-Fi. But these all 4 were like local, but now they all are like virtual. So 4 of these combined are given to a virtual repository. That's how things are. But releasing them to each repository was a bit hard. But now we have automated the entire process, and we tested same with 1.7. So within 10 minutes now we can do the release for Docker images. Same with the Helm repository. This part is done. Next, we were doing a lot of testing for our access gateways and simulation based like SRSRAN and all of these things on AWS. And we were facing a lot of issues when we are creating instances. So what we have done is we have written a lot of Terraform code for automating this entire process. So new spin-up will be created like that. And after that, we can spin up our access gateway, spin up our SRSRAN. So infrastructure-based code we have automated. The application deployment, we are still working with the ARM team and Meta team to automate this further. And yes, we are right now in a phase where we are migrating our old Artifactory packages to new Artifactory, and we are picking all the places where we have hard-coded the existing Facebook connectivity Artifactory and moving it to Magma core. And if you see like somewhere in the code that your code is pointing to the previous Artifactory, try to change it to the latest one. If that doesn't work, then just ping us on the DevOps channel so we can fix your code or update all the packages to the latest Artifactory, so you won't face this issue. Any questions so far? Okay, so I think yeah, we are good. Any other topic anyone would like to discuss?
Yeah, if there's still some time, I have a quick update from Canonical.
Yeah, please go ahead.
Awesome. So I'll just share my screen. This should be so the person that is sharing needs to stop sharing before I can do.
Yeah, I just, it's just giving me option. So yeah, I got it now. Stop sharing right there.
Awesome.
Is that good? Sorry about that.
No problem. All right, so this should be pretty quick. So I want to make this update about the snap for Magma Access Gateway. So we've been at work creating a snap for Access Gateway, and as you can see here, we have our first very edge version released. So it's not even beta yet. So you can play with it if you want. You can install it and you can look at it. However, we don't. I don't recommend you deploying it in a real environment for now. So there it is. You can look it up on snapcraft.io, and to install it, you click here, and that's the page you're going to see. And you should be. Oops. Sure. And you just click on install, and here you do a snap install my Access Gateway Edge, and yeah. So there's also a link to our GitHub. There's a how-to guide here to tell you how to install it and how to configure it so that you can connect your orchestrator to your orchestrator. And yeah, so that's all I wanted to share. You can also see the same stuff if you have Ubuntu. Here in your Ubuntu software store, you can look for Magma, and it shows up here. It's the same content. Note that it only works on Ubuntu for now. And also, it can be confusing, but in the bottom, it says that it works on multiple OSs. We'll have that removed. For now, it just works on Ubuntu. But yeah, I would say ignore the section where it says install it anywhere. So yeah, that's all I wanted to share.
Hey, Game, I have a few questions. How much time does it take to install the snap?
I would have to ask Bartek because he's the one that worked on it mostly. Yeah, I would say either do it yourself, or I'll come back to you with an answer as soon as possible.
And what version is this?
1.6.1.
1.6.1.
Yeah.
1.6.1.
We've
okay.
tested 1.7.2, and it should work. It's just that we haven't published it yet.
Okay, and this will create all the interfaces and everything, right?
Yes.
And will we have to reboot our system?
Unfortunately, for now, yes. But we have this in mind. Like we know how not nice it is to have to reboot the system, and we are working on it. But for now, yes.
Okay, great.
Yeah. Yep. Any question? Other question? So ultimately, like if you're used to installing Access Gateway, right now you are running a script. All of this now is abstracted. Like the same type of actions are done. It's just that you don't need to care about them. It's all done behind, and you can install Magma Access Gateway just like you would install any other application on Ubuntu.
The current process of installing is a mixture of Bash scripts and Ansible scripts.
Correct.
So,
correct.
Yeah.
Yeah. And like I said, like
yeah.
very, very beta. Like don't expect it to work perfectly. However, like if it doesn't work correctly, let me know. Like we really need to address those things. Like we have limited test environment. So maybe you're testing it in a completely different setup that we have, and we didn't think of your environment. So let me know if you want to test it and it doesn't work. Like we are interested in that. All right, that's it for me.
Any more questions for Guillaume? Okay. Thank you, everyone. Anyone have any other topic to share? Guess not. Thank you, everyone. Bye.
Thank you.
Thank
Thank
you.
you.
Goodbye.
Thank you. Bye-bye.
Bye.
Bye.